Hello everyone, I'm Sanis Puchivaya, and today I'll be presenting on the twin pillars of software quality assurance, which form the backbone of successful software development, software verification and validation, commonly referred to as V&V. Let's begin with a simple question. Why do software failures happen? Take about 5 seconds to think about it. Most people will answer code errors, and that's often true. However, the root cause is rather a mismatch between what we built and what the user actually did. This is where verification and validation comes into play. Each focuses on a different aspect of software quality, and together they ensure both correctness and user satisfaction. In today's presentation, we'll discuss how verification and validation differ, the key activities within each, why distinguishing them matters, and real-world examples illustrating their importance. Now let's break these two V's down side by side. Purpose. Verification ensure the product meets specification. Validation ensure product meets user needs. Execution. Verification is static, mostly involves reviews, inspections, or some functional testing. There is little to no code execution. In contrast, validation is dynamic. It involves running the software in real and or simulated environments. Focus. Verification emphasizes process, design, and code correctness, while validation emphasizes the final product, usability, and the real-world performance. Timing. Verification occurs throughout development. Validation typically happens after development or iterations, especially while using agile performance programming techniques like Scrum. Similarly, verification helps prevent defects early, while validation ensures that undetected issues do not reach end users. Verification is typically performed by developers and QA teams and is more objective, whereas validation often involves end users, clients, and QA teams and is inherently more subjective. Now let's take a 30-second pause to classify some common activities. Which of the following will you consider verification and which of them are validation? And well, if you have time, think about more activities related to each. Here is the quick answer set. Reviews, design walkthrough, and unit testing are verification. UAT and system testing are validation. Do you get those right? Well, unit testing is somewhat debatable. Some say it's verification, some say it's validation. Personally, I consider it as a verification activity because it focuses on the functionality of individual units rather than validating the system as a whole. Verification ensures that the software meets specified requirements. It's a systematic way of checking and double-checking throughout development to build the product right. Some of the key verification activities are shown here. The first one is requirements review, which means assessing the completeness, clarity, and feasibility of requirements. Another is a design document inspection, which evaluates architecture and design documents against specifications. The third is code analysis, which refers to checking code quality, adherence to standards, and correctness. The fourth key activity here is integration testing. It refers to ensuring that different modules work together correctly. The final key activity here is white box testing. White box testing refers to techniques where the tester possesses knowledge of the internal structure or code of the software. It focuses on examining how the system operates internally rather than just the outputs it produces. A common form of white box testing is unit testing, which verifies that individual components perform as intended when tested in isolation. Other examples include mutation testing, code coverage analysis, part testing, among others. While the most white box testing methods are associated with verification, it's worth noting that some can overlap with validation, depending on how and when they are applied. Exploring these methods and these nuances would in fact require an entirely separate presentation to discuss in depth. These activities are objective and criteria-driven, helping detect errors early and preventing costly rework later. Validation ensures that the software fulfills its intended purpose. It's about ensuring we are building the right product. Some of the key validation activities are shown here. The first one is system testing, which refers to assessing the complete system against specified requirements. The second one is performance testing, which refers to evaluating speed, stability, and scalability under varying conditions. The third one is usability testing, which ensures that the product is user-friendly and intuitive. The fourth one is user acceptance testing (UAT), in which the user ensure that software meets their needs. The next one here is beta testing, where real user tests in real-world or production-like environments. The final category is non-functional testing. These tests care not about features, but rather evaluate reliability, efficiency, security, and maintainability. We can include performance, usability under this domain. Unlike verification, validation is subjective and focuses on user satisfaction. It helps identify issues that may only surface in real-world users. When verification and validation are performed together and kept in sync, organizations gain multiple benefits. One is improved communication across development, QA, and client teams. Higher efficiency through early bug detection and reduced rework. Better resource allocation, focusing effort where it yields the most value. Enhanced risk management, fewer surprises in production, and helps minimizing failures in production. And most importantly, greater user satisfaction as the final product meets real needs. Now let's delve into some real-world examples depicting validation and verification. Based on the meme or picture on the right, can you guess which example I'm about to discuss first? Yep, you're right. If you guessed Mars Climate Orbiter, not a typical computer science example, but a well-known example and a popular internet meme. The Mars Climate Orbiter, built at a cost of $125 million and was a 638-kilogram robotic space probe launched by NASA on December 11, 1998 to study the Martian climate, Martian atmosphere, and surface changes. The spacecraft software passed all verification tests. It met every technical specification. However, the software used imperial units while the spacecraft expected metric, a classic validation failure. The result, the orbiter was pushed closer to the planet's atmosphere, where it presumably burned and broke into pieces. Pretty expensive lesson that passing verification alone does not guarantee success. Validation is essential. Now let's look at a more computer science related problem, a classic e-commerce platform design. During verification, developer and QA teams review requirements, perform peer inspection, and verify every listed feature, such as discount and tax calculations, checkout features, is implemented according to specifications. During validation, beta testers simulate real purchases, evaluate the shopping experience, user interface, and overall customer satisfaction. In other words, run the app on a real device, execute usability and functional tests, and gather feedback from actual users to confirm the product meets their needs. Now let's look at the classic V model that visualizes how verification and validation map onto the software lifecycle. Starting at the top left, we capture user requirements, then progressively refine them through architectural, module, and component design. That whole left-hand side is where verification lives. Each artifact is checked against the one above it, ensuring we are building the product right. Once we reach the bottom of the V, development is complete. The right-hand side of the V is mirror image, unit testing, then integration, system, and finally acceptance testing. Most of the activities are validation. We run software, involves end users, and confirm that the built product actually meets their needs and works in its target environment. This mirrored structure ensures that each design decision is later validated, and each test traces back to a requirement. Skipping either side breaks the feedback loop and can lead to the kinds of failures we discussed earlier, like the Mars Climate Orbiter. In today's fast-paced development environments, Verification and validation are no longer sequential, they happen continuously. Automated unit tests provide ongoing verification. Continuous user feedback loops through telemetry and feature flags provide continuous validation. AI-assisted tools now help automatically generate test cases and detect specification mismatches, accelerating both V&V processes. According to a recent practice survey, 63% of organizations are actively automating their QA efforts because developers spend over 50% of their time debugging, a clear statistic that clearly shows the importance of a robust V&V integration. To wrap up, verification ensures we build the product right. Validation ensures we build the right product. And together V&V ensures that the right software is built correctly. Both are indispensable components of software quality assurance. Neglecting either can lead to technical or practical failures, sometimes at enormous cost. Thank you for your attention. Happy coding!